Welcome to Doozer Shop. Thursday. Just felt like making a video right now. Been doing some things here in the shop in the evenings. Just trying to get some projects complete. Let me take you handheld and get right into it. Been working on the Pratt and Whitney 2A jig bore. And let's go look at what I've been doing on the jig bore. Okay, first off, let's see. The sight glasses were leaking. It's a bolt-on sight glass. This is a new piece of plexiglass. You can see I put it in there with orange silicone sealant, and the back, the diameter of that, you can see the reflection of the ceiling lamps, is 1.25 inches in the back, and the small diameter is 1 inch exactly. So I had to use a piece of plexiglass, 1/4 inch Lexan. Okay, Lexan is a brand of polycarbonate made by GE, I believe, and it was 1/4 inch, and I needed 3/16. So I took a 1/16. So this is full thickness, and I stepped it where the glued area is, where it's orange with the silicone. That's a 1/16 trepanned in there with a boring head and the Bridgeport. This is the original one, and this is plastic as well, Perspex, or there's different names for it. You can kind of see that rust stain, or it's not a rust stain, it's an oil stain. I don't know why I said rust stain. That's a crack inside the lens, inside the plastic lens. So it was seeping, and you can kind of see the crack wants to jut off to the left there and jut off to the right. But you can see the oil stain. But this thing was junk. It's even got a step inward. Mine steps the other way. But I made a new one nevertheless. So this should be good, and I put it in the Kurt Vise overnight to let the silicone dry. It's amazing, when it gets thin, the color gets opaque. You know, the orange goes away. But I promise you, I had a bunch of silicone on there, and I had the paper on there. Whatever. So that's yet to go on, the Pratt and Whitney. So let's take you over there. There's some adjusting nuts for the leveler feet. Let me just put these. I don't think I'll put these on. I wire brushed the snot out of them, and I painted them. But you don't need jam nuts on adjusting feet. I don't know why. It's not like it's going to move. But I gave them a coat of black paint, just a real quick coat of paint. And I'm just going to put them on a cable tie, a zip tie, and throw them inside the machine housing. But I just didn't want them to rust. Anyways, I turned to the high bay. So this is the low bay, right? This is the shop proper, the low bay. Some of you may be new to the channel. And then there's a wall and a door, right? And the ceiling in the low bay is 9 feet, and it's 14 feet in the high bay. Many projects. So you're going to see pistons. This is an international, forgive the tub of plastic whatnots. This is a 6-cylinder to replace the 220 cubic inch engine in my truck. I bought this one with low miles, but it had water in it. This was a 264. So 220, they made a 240. That's in my other truck. This is a 264 cubic inch. That's what the pistons are all about. So here's the shop layout as of today, subject to change. The jig bore is staying. I believe that's a 1958 Pratt & Whitney 2A. It's got Navy tags all over it. And the scraping is wonderful. I don't think they use this thing hardly at all. Maybe previous videos, not sure. I was cleaning the Kearney Trekker 2CH. So that's diagonally in that corner is the 2CH. The held grinder, I'm trying to move it around. The Pratt & Whitney is in this corner. Boy, you really got to back up to get it in frame. There you go, man. It's 10 feet tall, and it wouldn't fit in the shop proper, so I stood on top of there. Yeah. And then the Miltronics CNC Bridgeport is in this corner. And don't even look, I got my surface grinder over here. I think I'm gonna leave it there. Because if you look in the door, it'll shoot the sparks. I mean, it's got that catch shield, but the dust is generally gonna go towards that direction. And I can close the door if I'm grinding. Whatever. And I still got another Detroit engine. I got a 6ZF, and I got rims to paint and dividing heads and spacing heads and another. That's the 4-speed for my International. But anyways, let's show you. Well, I'll put the ladder over there. All right. So I cleaned this one. This one was not cracked, but it was dirty. And the white background is actually, you know, the background is the casting. This is all one piece, and these two little holes inside there is actually drilled in the head of this. So you had to paint it. I used paint marker, and repainted it, and put some Hylamar sealant on there. Hylamar is like blue silicone that doesn't dry. It's only, I think, produced in England. Kind of neat. Big old motor, very much like the Clearman drill press. Similar probably mounting situation and sealing situation. Thank God that thing's not leaking or messed up in any way. And inside here is the column. There's a weight inside there. And there's the chain, the counterbalance chain. Goes up and in, and there's a big weight in here. And that hole right there, I think is a barring. You can stick a 1-inch bar through there, and when you transport it, you can immobilize the chain. There's another hole there. Whatever. Interesting note. Oh, there you go. Ta-da, 2A. U.S. government. Anyways. So in the gearboxes, use Mobile Veloset E, which is a viscosity of, I think that's Stay-Bolt units at 100 Fahrenheit. And if you translate that to ISO, it's like ISO 10. It's very light oil, ISO 10. Usually I use 32 ISO, anti-wear 32. 32 is very thin. And then I use some 68. I'm wondering if I can use 32 ISO instead of 10 ISO in here. Because for gears, I think it should be 68, which is like 30 weight SAE. And I believe 32 ISO is like 10 weight SAE. And this 60 stable units or whatever at 100, that's not 10 SAE, that's 10 ISO, which is like less than 5 SAE. It's like 2 weight oil in SAE. So my question is, do I really want to run like SAE2 grade oil or weight oil in a gearhead and, you know, the power feed box? I don't know. It just seems awful light for ISO 10 or SAE 2 or 3, I forget. I just want to use 32. So the reason they probably say that, I'm stepping on stuff, is you know, they don't want this to heat up. And any oil with a, you know, viscosity is going to generate heat from just the friction and stiction and all that jazz. And this is the feed box, which also calls for that oil. Let me move this thing. All right. There's the, what you see, I've been using the white paint marker, just dabbing it in there. I got to put a couple more coats on, but that's what it is for the sight glass. Let me move back. But anyways, and that's got worms in it. There's, I think, 2 worm gears in there, maybe 3. And worms want like ISO 220. It's just thick oil for worms. That's why I hesitate to put, you know, Velicet number 6, I think, or, you know, ISO 10 weight oil up there. I talked a lot about that. I'm sorry. Anyways, some of the things that I did on this machine. I'm going to sit down in this chair and roll. And what I'm going to show you is this. So see that aluminum housing on the bottom? It's like a kind of a teardrop shape around the spindle quill. That was a cast iron piece, and it was cracked in a bunch of pieces. And I drew it up in SolidWorks out of aluminum. And my friend Angel made that on the CNC for me. And it's more complicated than it looks on the inside. There's a groove for a bronze ring that is a wiper that floats on the quill. And there's a felt seal that is tensioned by that wiper ring inside there. There's like a 3 or 4 step sealing labyrinth in there. So thank you, Angel. Thank you a bunch. And I needed felt that was an 1/8 inch thick and 5/16 wide and 16 inches long. But I had not 5/16 wide, but 5/8 wide. So to cut the felt, I spaced it up on a parallel in a Kurt vise and squeezed it with the appropriate amount of stick out the top of the vise, and I just used a razor blade and trimmed it a couple times and made my felt. So thank you, Angel, you know, for that. That is one awesome sauce piece. Okay. Look at that scraping. This thing is gorgeous. Very faint, not faint, but there's your serial number. But I went over all this with a carbide scraper just to show up the scraping. It's got rust stains in it, and it's not terrible, but I scraped all this, just removing nicks and, you know, bumps and stuff. I took off the gauge block troughs and the gauge block, you know, where the dial indicator holder was there. It just, I'm not going to use it with the digital readout. And there's one down there that I took off. But these things, so, you know, that's the Y screw, the in and out screw for the saddle. And there's a big double row bearing in there, and the bearing was floating like it was missing shims in this housing. It had about 25 thousandths of axial float in there. So I had this whole thing apart, and there's a worm gear in there, and double cone clutches. I ended up finding a piece of copper wire, and I wound it in a circle like a bracelet, and I used that to shim the bearing. And this cap has 4 Allen head screws. That's how it comes off. And there's not even a couple thousandths or nothing in there. So the way this works is, so when you tighten this in, it's like, that's the one way. That's direct moving of the table. And the spider in the center, I think is it this way? No, it's like, loosen it. That's a neutral, right? So let me try to do this. If I spin that and then tighten the spider, it locks the clutch. It locks it, and it's trying to move the table, right? But if you loosen the spider, so then the clutch is a neutral for the wheel, right? And you move it out, and on the outside, then when you turn this fine adjustment wheel, it turns the whole, maybe you can see the orange wheel movement? No, but it's moving the, well, you can't see nothing. There's a nut. I'm shaking the camera too much. But trust me, this is the fine feed. And it is moving. Tighten counterclockwise is the worm fine feed. Middle is neutral. Actually, I think this is neutral too. Yeah, this is neutral for the hand wheel. And when you tighten it, it locks the hand wheel. So I'll leave that in neutral. But yeah, there's double cone clutches in there. Kind of neat. This is the, there's 4 electrical windings in the motor. Winding 1 is 800 RPM, 1200. I think it's 600, 800, 1200, and 1800. And 1800 is 5 horsepower. And there's a big drum switch with like universal joints and everything. So that's fun. The main motor start-stop is there. The drum switch is just for selecting speeds with the windings. Now, this has 4 geared, 3 speeds, and then it goes here, of course. So from a low of 37 to a high of 1800. So that's cool. That was a lot of work. So it's got some brackets for a digital readout that I took the old readout encoders off because they were shot. There's a Teledyne Guillery. Oh, this handle was bent, right? Thing was bent like maybe 10 degrees. So I had to take that out. You can see the 2 double nuts underneath there. That's the table lock. So I took that one out and straightened the shaft, and it took a while. Did in the press, the K.R. Wilson. Behind the oil can, there's another lock handle. What I want to show you is the adjuster feet. There's 1 on each side and 1 in the back, so there's 3. And that's a stabilizer. See, I'm not going to take your own back. There's 1 around back. So the main ones are there in the front, and then these are stabilizer jacks. But anyways, I made floor pads to receive these screws out of 1/2 inch plate, bar stock, 1/2 inch thick bar stock, 3 inches wide, and I end up cutting them 7 inches because they got to go underneath the machine. And I counterbored. So all this was rusty. I took all the screws out. That took hours because they were rusted and the threads were goobered up. Wire brushed them, chased all the threads with a triangular file, cut, these just had blunt points on them. I think they're 1¼ inch thread or 1 3/8 thread. Had blunt points on them, so I cut dog points in the lathe. The first couple threads I removed, cut dog points, and then I put a 10-degree cone on them so they'd spin. And on this 1/2 inch plate that's on the floor, I turned the dog points to exactly 1 inch, and I put 1 inch, using 1 inch end mill, and bored a 1 inch recess with the 1 inch end mill, an 1/8 inch deep, to receive the dog points of these screws. And I think these are 1¼ inch. I think the middle ones are 1 inch. Everything was so rusty, and it had those nuts on them that I showed you first off. I had to get the cutting torch and cherry those up red and get them off while they were red hot, because man, the thing was just rusty. So now they're in there with NICs, Molly lubricant, and I'll show you. There's 1 in the back. There it is in the back. The ways come right to the back of the machine. This is the back of the column. The ways come all the way back. That's actually the saddle you're seeing there underneath the hole in the column. Just a cool deal. Just neat. Let me show you. Let me crank this out. Crank this out. Tighten it and move the table out. It moves like butter, man. This thing actually moves pretty darn easy. Do I got enough showing? Yeah. So one of the things that I did is I eliminated the one-shot lube system. Forgive the pistons and the lifters. Folks, keep your lifters in order. You can reuse them. Drill them in a piece of wood and write the word front on it for front of the engine. Anyhow, that plate, these are all, you know, flip top oilers, Gitz cups, individual oil hole covers. That was lubrication lines. And I made a new cover, and I bought some cups on eBay. That took a while. And then this is an aluminum bar that bolts to the back of the table. And this had oil lines going to it. And these are 1/8 inch pipe thread. And these are a little bit bigger, but as you can see, that's converted again. So 6 and 1, 2, 3, so 12 oil cups this has. And there's some oil cups there, and there's some there, and there's a few everywhere. But that's what I did for the oiling system, okay? And I still gotta get this engine together. Let me do this real quick. I got an electrical cord just in there on and I got a piece of wood jammed in the contactor, so it's on. So what this is just doing is I got the VFD here, right? The VFD is plugged into the wall, 220 single phase, and then I got the twist lock going in there. So let's turn it on. And I'm at 30 hertz, so let's turn. Can you hear it? So that's at 30 hertz, half speed. Nothing's moving yet. So you gotta throw the clutch. Come on, lamp. There you go. Is that the fast? I think. No, that's the low. Let's go. There. So I'm on 600 because I'm in low. It says 300 because I'm half speed. So this is 300 RPM. I'm gonna sit down now. So, thanks for, checking out what I got going on here with this machine. Pratt & Whitney 2A. And I'm really happy of the progress I've made. But between the adjusters, and I've been cleaning the ways, I've been doing the oiling system, I gotta finish the electrical stuff. I'll probably VFD it, even though it is a 4-speed motor. But thanks for coming along with me and checking this out this evening. And I hope you like it. This is such a cool machine. Till next time, this is Doozer Shop.